Pandas Advanced Part 2. In this video, we will focus on how real analysts work with large datasets efficiently. You will learn how to reduce memory usage and speed up operations and handle large CSV files the right way. So these are practical skills that make a big difference in real projects and interviews. Okay. So before that, I'm doing this in Pandas Part 1, and we need to run all these cells together so it will run correctly. And I also mentioned the Pandas Part 2 here. So while you go through this file, you can find both Pandas Part 1 and 2. Okay. So our first code is to check the memory usage. Okay. For that, I'm using df.info and memory usages. We are giving deep. So before optimizing, always check the memory usage. This tells you which columns are using the most memory, or where optimization will help the most. All this. Okay. Here the memory usage is 1.4 KB. That's really a least amount. So that's okay. We are moving to the optimizing data types. Okay, for that, we are taking department, that is df department, and we need department equals df department, and we need to give dot as type, also the category. Okay, then run. We can run using shift plus enter. So we can also do that df salary, then salary equals pd dot to numeric, because salary is in numeric value. We need just to convert it, and we are adding df dot salary, df salary, and then we need to add the downcast equals integer. Okay. So here we got an error because our salary is placed as salary and the dollar sign. So we just replace that with a dollar sign, and everywhere we just need to replace. Okay. Run it again. We find another downcasting method provided with an error. So here we need to add the dollar sign, and we need to run it again. We will definitely want to get the error, and I will say why. Okay, so here is the value error, invalid downcasting method provided, because here is a unwanted gap. So this space should be cleared. Now let's run again. So now it's fine. Okay, so using correct data types is one of the biggest performance improvements you can make. So categories and smaller numerical type values can reduce memory dramatically and speed up our groupby operation. So that we took the department and the salary because it contains the category and the numerical values. Okay. So we found a error here. That's just because we had a gap in between the string. So because of that, we got an error. So while doing operation, just make sure you don't give unwanted space. Okay. Now we're gonna use assign for cleaning pipelines. Okay. For that, I need to add df equals df dot assign, and then salary, k, we are giving k, equals df salary with dollar sign, and then we need to add slash 1000, okay, separated by a comma, is high earner equals df with salary and dollar sign, then which is greater than 80,000. Okay, so we got an error here. Okay, we can go through it, and we found it's just because of that underscore. Okay, we can run it. Now what we done, I assigned the method assign, and helps to build and clean readable pipelines. Here you can see I use salary k to define df.salary by 1000, and is higher earner. We give a condition that the salary is higher than 80,000. So assign is a method which helps us to build clean readable pipelines. We get a clean readable pipelines. As you see here, we had two of that. One was salary, K and salary by 1,000. Also, we added is higher earner with a condition. So this helps us to create multiple features. It's a professional way of doing the workflow without doing so many lines. We are just keeping it in a single line using the method assign. Okay, you got it? So here we used assign, a method which helps to build clean readable pipelines. This is our pipeline. We used assign method. That's it. Nothing complicated, nothing to worry about. We just used multiple features with the help of the assign method. That's it. Nothing more. Okay. Now we are going to do vectorized operations. Okay. For that, I need df bonus and then equals s star 0.1 for s in df salary with dollar sign. Okay. We done this. Okay. But it's a little bit slow method. We don't want slow, but we want something really faster than this. For that, we are doing df bonus and equals df salary. Afterwards, star 0.1. Just run. I didn't mention the dollar. So everything ran precisely. Never use Python loops on Pandas columns because vectorized operations are much faster and are how Pandas is designed to work. So because of that, using loops will be good, but it is slow. Okay, so use vectorized way of operations which make the code much more faster. I hope it's clear. Okay. Then if you want, we can just take the df bonus here, then run. So everything is in float type as you see here. Okay, we can run everything like this wherever we want to run. We can just run df department. And to know what did we do here, what are the as type categories, the type here you can see the data type changed to category instead of string. Here we can analyze, it turns to integer. We can just take these and write salary. So under this we can see this as int 32. Before this, while going through the info of everything, it was float and the department was category. That's already category, and but the salary was in float. Now we change that to integer. Okay, because we can save the storage if we take it as an integer. Now we are going to efficient filtering with query. For that, I am using the variable high paid equals df dot query with salary is greater than 80,000, and we are using and in between department is equal to equal IT. Okay, so we need to add the quotes in between. Okay, now run. We may find a is because we use quotes here. That's not necessary because here it's a type error, not supported between string instance and int. So we are doing an operation, and if we take the salary as a string, it may not work. Because of that, we remove the quotations in salaries and we give quotations to IT, which is a string or a category. Okay, now let's run. We get a Python validation identifier. As we see here, we got a error, and we are just going to find that out. Here we got a space. It's because of that. No, there is no space. If we gave 2, it may have a error. Okay, so that's not the thing. So what's it? Let's gonna find out. Okay, now in the left side of number 1, you can see a backtick or back quotation. So just use that back quotation both places in between our column name. Okay, let's try this out. And let's try, and that works. Okay, now I explain why. Because in Pandas, we are using a lot of things like we use assign sign, then we use single quotation, double quotation, and greater than, all this. So Pandas got confused. So in these cases, we just place a column in a backtick or a under the quotation, back quotation. Okay. So it will sort it out and we will get the output clearly. Okay. I hope you get it. And we can find that back tick left side of the one or under the escape. Okay. So that's it. So queries make filtering cleaner and easier to read, especially for complex conditions. As we do here, we got a error, we got so many errors, but we sort it out. We sort it out in live and we found why it happened and what are the precautions we can took next time if we get something like this. Okay. Now we are moving to chunking large CSV files. That's a real world project. Okay. And we can use large data CSV files for that. So I need to find my Kaggle account and find some CSV files. Okay. So I'll go through the Kaggle and I'll find the Kaggle and download dataset. I need some CSV file which I can take anything from here. So I'm looking for a CSV file. We just write it. We will get so many files and we can download any of it. From here, I would like to download the first one itself. We can take this datasets. Datasets are in CSV files. So here you can see Titanic in all one CSV file. Yeah, we can download it from here. So we will find download the data in zip. So download the zip from here. Then it will be downloaded here. Then we get this. We will be looking that in a folder and we will just extract it. Okay. I will go and I'm going to extract all. Then I'm going to place the file destination as Titanic. Okay, and I am extracting it. You will get all this extracted file here. Then close it, move to our place. That's our code. And then here you can find the option, find Titanic, then add it to here. You will get a warning. Okay, that's okay. Now the file is extracted. Okay. Now we need to rename the file all in one to just Titanic. Okay, it will be renamed. And the next thing, that's chunking large CSV files. So for that, we are looking chunks equals pd.read CSV. Then we are taking Titanic. That's our file name .csv. We added that. Now chunk size, we need to add the chunk size also, comma. Chunk size as taking about a lakh. And then we are adding for chunk in chunk. Print, we need to print chunk dot shape. Okay, then run this. We got the same shape as 418.2. Okay, so when files are too large to fit in memory, we can process them in chunks. Chunks means small parts like simple pieces, fragments. We can say all that. Okay, so you can process them like in chunks. This is extremely common in production and while we are dealing with real analytics pipelines. Okay, now we are moving to our department salary and all. For that, here I'm using df.groupby and I'm adding department. Then I also want to add observe. Okay, now I added the observed equals true. And I'm going to add the salary $sign. It's important. Also dot me. So using observed equals true, we added this because we need the groupby in parentheses. Okay, so using observed equals true with categorical columns improves speed and avoids unnecessary group bys. Okay, so we already placed department under category. Because of that, this group by works so simple. And it also helps us to improve the speed. Also, it avoid unwanted groups. All this. Okay. Now, when datasets becomes very large, like too large, pandas alone may not be enough. Like we are dealing with pandas, that's so simple. We are just dealing with some codes. We know many codes now. We all deal with group by, observed, or chunks, or maybe query. All this we learned a lot of codes. But when it's come to large datasets, pandas cannot do all this. Okay, so that's where we use tools like DuckDB and SQL, which are something really important when we learn about data analyst. So which we will cover in next series. Definitely we want to cover that because it's Pandas advanced too, and we need to cover all the Pandas advanced part. Afterwards, we will definitely cover the SQL, what's DB, all that which is necessary for the data analyst. So today we learned a lot of things in Pandas advanced part 2. You learned how to optimize memory, improve performance, and work with large datasets like a real analyst. Also, we found the Kaggle datasets and we downloaded it, we extracted it, we named it, and then we found DF of assign, which is really important one for us. Also, we found bonus, which is just a loop, and we found out that pandas columns vectorized operations are much more useful and speed up process than just going through loops. Okay, so we found out all this, and we added df dot query. We learned about where to use the backtick or the back quotation, all this. And in the next video, we will go deeper into advanced indexing, multi-indexing, and complex reshaping used in real projects. Okay, so I hope everything is clear because I need you to understand why we used all these simple codes here and we just do all this debugging in live because we need to learn, we need to study, we need to apply. We just don't want to go through this without knowing what happens, or we don't want to stuck in between. Because of that, we debug all these things. Okay, I hope it's a good class for you and you understand the advanced level part 2. So I really thank you for watching this, and I will see you in the next advanced lesson for sure. Okay, bye bye guys.